distinguished delegates and dear colleagues, please take your seats. So I hope you have a lot of energy. So my name is Shiroma Satyapala from FAO, and I have the pleasure of welcoming you to this session on the role of forest genetic resources and integrated management of pests and diseases in maintaining healthy and resilient forests. Under sub-theme 2, on nature-based solutions for climate change adaptation and mitigation, and biodiversity conservation, and I will also moderate our discussion today. I would like to take this opportunity to thank you and our partners, the Alliance between Bioversity International and SEAT, the World Agroforestry, for collaborating with the FAO Forestry Division in organizing this session. As most of you know, healthy and resilient forest and agroforestry systems are crucial for safeguarding biodiversity and maintaining ecosystem services, as well as for climate change adaptation and mitigation. Our 15th World Forestry Congress theme also, building a green, healthy and resilient forest. So such forests and agroforests can also maintain their productivity under changing environmental conditions and thus continue to provide goods and services essential for human well-being and sustainable development. Today, we are experiencing increasing incidents of extreme weather events. We hear about droughts, we hear about floods and tsunamis. Climate change is expected to increase the outbreaks of existing pests and diseases and expose forests to new threats. These risks, when they materialize, can increase tree mortality, result in changes in tree species composition in a given site, and even lead to widespread forest decline. This can have a devastating impacts of local communities and economies. I really want to take you back to Monday. I hope on Monday you all have visited our first session under this sub-theme. On Monday, during this first session, under this sub-theme, we heard the definition of nature-based solution adopted by 5th UN Environment Assembly. Can anybody recall it? No, I'm not going to ask you. Let me recall it. Nature-based solutions are actions to protect, conserve, restore, sustainably use and manage natural or modified terrestrial, freshwater, coastal and marine ecosystem which address social, economic and environmental challenges effectively and adaptively, while simultaneously providing human well-being ecosystem services and resilience and biodiversity benefits. Definitely it is very difficult to memorize it. But the key is, it's very clear that actions to protect and conserve. So then genetic diversity as well as integrated pest management are nature-based solutions for continued adaptation of forests to climate change and for safeguarding biodiversity. Moreover, genetic diversity provides both resilience and resistance to stress factors and forest disturbances, fire, such as outbreaks and pests and diseases. Genetic aspects need to be considered more carefully while managing existing forest and agroforest, and while establishing new ones. In particular, these aspects are crucial in the selection and production of seed and other reproductive material for reforestation, restoration, and other tree planting efforts. Today, countries are planting millions and millions of trees, thinking about a green future. So that is why we need to be careful and select the right species which is not only suitable for today, but also suitable for the future. During this session, we will hear recent advances and experiences in managing forest genetic resources and in controlling the outbreaks of pests and diseases. Our program consists of a 20-minute keynote presentation on recent advances in integrated management of pests and diseases, It will be followed by short intervention by 4 panelists who are joining us in person and virtually. The rest of the session is devoted to a panel discussion, and you are welcome to make comments or present questions to the panelists. Now, before kicking off, let me share some guidance on how to engage in this event. The session will be conducted in English, and simultaneous translation is available in French, Korean, and Spanish. The session is a hybrid event, and virtual participants have the translation available as well. The virtual participant can post their comments and questions using the chat function. In case the time doesn't allow us presenting all your comments and questions to the panelists, they will be considered when preparing the summary of this session for tomorrow's morning plenary. Now, let us begin session with the keynote presentation. The keynote presentation is Integrated Management of Forest Pests and Diseases, a nature-based solution in West and Central Africa. So all the way from Africa, is presented by Professor Paul Bosu. Paul Bosu has worked for the Council for Scientific and Industrial Research, or we call it CSIR, of Ghana over 25 years, mostly at the Forest Research Institute. And he is currently Director General of CSIR. He has a PhD in forest sciences, forest entomology, and his research has focused on the management of pests in planted forests in his home country and in the humid tropics of Africa. Paul is a founding member of the Forest Invasive Species Network for Africa, which is one of the 4 regional networks facilitated by FAO. He also participated in the African Forest Forum study to assess the occurrence of and the impact of forest insect pests and diseases in Africa. Paul, you have the floor.
Thank you very much, Sheroma, and welcome to everybody once again. So with that very elaborate background, I'll just go ahead and mention that my presentation is going to focus quite a bit on the integrated pest management, IPM, as I will be saying, and we'll be focusing a lot on what has happened in the West and Central African regions. Quickly, I'll first give a brief definition of IPM, integrated pest management. I'll mention briefly the forest of West and Central Africa, forest pest problems in West and Central African region, IPM strategies that we have used, we have tried, IPM strategies for invasive native species or indigenous species, and then the IPM strategies for introduced species. And then towards the end, I will give a specific example of what we have done in a particular plantation. So what is IPM? And basically, it's an ecosystem-based strategy. It's an ecosystem-based approach that is aimed at managing the pests rather than controlling. I put them here. Managing means that the aim is not necessarily to eradicate the pests. The aim is to ensure that the pests are managed in such a way that they are kept below a threshold, whether economic or environmental or social threshold. So it's a management approach, and it focuses on long-term prevention of the pests through monitoring, forecasting, detection, and then slowing the development of the pest population. And IPM uses a number of strategies. One of them is to use genetic resistance. So instead of just putting anything there, susceptible individuals or species, you identify resistance and then you use it or you manage it. You also can use biological control, habitat manipulation, modification of cultural practices, silvicultural practices in the case of forestry, and sometimes, if absolutely necessary, the use of pesticides in a very much controlled way to achieve your aim. Let us just remind ourselves of the disease triangle. If we are talking about integrated pest management or pest management in general, then we have to remember that pest management or pest incidents rest on three items: the host or the tree that is susceptible being attacked, and then the pathogen, which is going to attack the tree, which in this case could be an insect, could be a virus, could be a fungus, whatever it is, and an environment that has been created. So these three factors come into play to ensure that trees are either healthy or forests are either healthy or they are attacked. And you take advantage of the disease triangle to provide the IPM strategies that you want to. Quickly to the vegetation types that we have in the region. That whole region, that continent of Africa, you can see there, and the red rectangle there shows the area that I am talking about. The dark green, or perhaps black looking on the screen, is the area in West Central Africa where the forest is very rich, highly diverse, as you can see on the picture in the left. Of course, a lot of it has been degraded or deforested, but that's the area where we get most of the timber trees that are very important in economies. It's the same area we also get a lot of NTFPs. The lower left picture shows a leaf wrapper for wrapping food. The right one shows ladies in Ghana selling mushrooms that they have collected from the forest on the right. So we need to maintain, if we need to maintain a nature-based sustainable forest, then we need to have a forest that has all these things into play. The forest of West and Central Africa, as I mentioned, are very diverse, very rich, but as we have more degradation, we have more deforestation, there has been a need to enter into plantation development. Unfortunately, the very high-value species that fetch more resources, provide the diversity that we need, are highly vulnerable to diseases and pests. And many of these diseases and pests are actually endemic. In the natural high diversity, they don't show up, though they are there. If we put them in plantations, then we have very serious problems. And that has caused a situation where we haven't been able to do too well with native species plantations. I have here three very popular species, highly valuable trees: the African mahoganies, we have the kayas, the entadrophragmes, all of which are highly susceptible or vulnerable. We have the iroko, which is milicia, very good timber, and nuclear. So this picture here is the Phytolima is an insect that attacks the iroko tree, the Milicia excelsa or Milicia regia. You can see the insect there, and it causes gall formation. So those big things that you see are the leaf galls as a result of the insect attack. And it easily can cause 100% mortality in nurseries. In the field, it slows growth, causes deformity, and hardly leads to any timber or any good timber without any intervention. We also have the mahogany shoot borer. I think this is fairly well known because of mahoganies also in Central and Southern America. It has the same thing. The insect there is Hypsipila. It's a shoot borer. It causes massive deformities, sometimes causes mortality at the nursery, and then because of the branching, excessive branching, it reduces the value of the trees. We have this other one, less popular, but the tree is very valuable, Aphromosia. Has also this leaf roller or defoliator, which causes a lot of problems. And there are several others. I just picked these three as an example. So what IPM strategies have we used in the region? The first one is host resistance breeding. So as you can see, we have done host selection of resistant individuals from across the range. And I mean that across West Africa, all the countries that have the tree, militia, and all the way to Central Africa, even to East Africa, where we have militia in Tanzania, so that we can develop, select, and identify resistant genotypes for planting. We have done fairly well on that. The same with mahogany, the Kaya everensis, Kaya antarctica, and all that. We've done a lot of considerable work of selection of resistant or tolerant species, and some work on Nuclear didericae. These are all species that we have done selection for. The next strategy, if you remember the disease triangle, is the cultural strategies that we have used. So for cultural strategies, we have used mixed species planting approach. We realized that for the native species or the indigenous species, by their nature, in the natural forest with high diversity, they are able to stand against massive or dangerous pest damage. So why don't we just introduce these species in a mixed form? So we have conducted trials using 5 species mix, 10 species mix, and it's a way to keep the trees very close to their natural environment. And we've seen considerable degree of success. We've also done what we haven't done, what we intend to do now is to actually study the inclusion of resistant genotypes or resistant species into mixtures. We have done trials. We just don't have the data for that, so we'll do that. And the next thing is enrichment planting. Enrichment planting, as some of you may know, is basically planting these high-value species in degraded forest. So you don't clear the forest. You identify or you look out for the gaps in the forest, and then you put these species there. And it's also a very high diverse area, and it's able to get these species to survive. So the picture there, these 2 pictures, will show you some of the mixed species trials that we have conducted. These plots are now very old, very grown, and we have some of these high-value species surviving under them. And then one of the things that happened was in the past 2 decades or so, when native species were not doing well, then the thought went to, or the attention went to exotic or introduced species. So most of the plantations in Ghana today and in the sub-region, you have teak, we have the cedar or the cedrela, you have eucalypts, melina, pines, and so on. They seem to be doing well, or they seem to be doing well in the past. Now the situation has changed. They are also becoming vulnerable, and it's because endemic or native pests and diseases are now adjusting to them, and they are utilizing them. So the picture you